The following is the video solution from JSDT Solutions. Question 5 says, sketched below is f of x, which is equal to negative half x squared plus a half x plus k, and h of x, which we can see is an exponential function, is q to the power of x. The x-intercepts of f are b and c. H and f intersect the y-axis at d. Okay, so there's a missing y-axis over here, so it just connects like that. So they intersect at D, as we can see there. And then they tell us that A is a point on H vertically above C. So this is vertically above C. So they share the same specific coordinate. It could be X or Y. You need to remember that. And they say with a Y value of 1 over 4. We should probably put that down. So this has a y value of 1 over 4, meaning it's currently just x and 1 over 4. Let's just keep that like that. And then they tell us that PR is perpendicular to the x-axis, as we can see. Let me also just extend that line. And the first question is calculate the coordinates of D. So where is D? D is specifically the y-intercept of the graph of H and F. So do you see that F is not complete? K is missing. Okay, so we can't really look at that y-intercept from there. So we're going to have to rely on H. So H, you can still find it because of the way it has been written. H of x is simply just q to the power of x. To find the y-intercept, you need to make x equal to 0. So that's what we're going to do. We'll say h of 0 is equal to q to the power of 0. And anything to the power of 0 is equal to 1. So that is D. D, the coordinates of D are 0 and 1. That is our y-intercept. Moving on to the next question. The second question, 5.2, is to write down the value of K. So we saw how K is also the y-intercept. Okay, it's the y-intercept of this graph of F because it has been put in its standard form. So that is the y-intercept. So the value of K is also equal to 1. So K equals 1. Moving on to the next question. Question 5.3 says, calculate the length of BC. Okay, so what is the length of BC? Let's look at BC. Okay, B and C are x-intercepts of the graph of F. So we would just have to find the x-intercept of this graph. Let's just ensure that we fill in what K is as 1. Okay, so this is the graph of F. And to find the x-intercepts, we simply make y equal to 0. So we'll say 0 is equal to negative a half x squared plus a half x plus 1. So we can say that there is a common factor all through of negative a half. So we can divide both hand sides by negative a half, or you can choose to just multiply both hand sides by negative 2, okay? Because negative 2 over 1 would be the reciprocal of this, and it will cancel that negative 1 and the 2. And what we do on the one side, you must do on the other side. So we're multiplying both hand sides by negative 2. Okay, so this now becomes, when it multiplies in, that becomes x squared. When that multiplies, that becomes negative x, and that becomes minus 2 is equal to 0. And let's factorize. So what times what gives us x squared? That is x times x. And what times what gives us 2? It's 2 times 1. But this is negative, so one of them should be negative. Which should be negative so that we can ensure that the middle stays negative. You should make the bigger factor negative. So negative 2 plus 1 equals negative 1. So that's that coefficient there. So therefore, this means that x is equal to positive 2 or x is equal to negative 1. And now we can just look at which ones would be B and C. This is the negative, so that is negative 1, and that is positive 2. That is great, and that really helps us a lot with A. Okay, so we can just tell them what B and C are. So the coordinates of B are negative 1 and 0, and C is 2 and 0. And so to find the length of BC, seeing that this is a vertical line, all you have to do is count that distance. You can decide to count it like this and say, oh, that's 2 units, okay, to the right. And that's 1 unit, and that's therefore 3 units in total. Or you could just say the higher x value minus the lower x value. So we can say that BC is simply equal to 2 minus -1, which is equal to 3. And that is our answer. Question 5.4 says, calculate the length of PR if OP is 2 units. Okay, let's look at that. So they want us to find PR if OP is 2 units. Okay, telling us that OP is 2 units, how does that help us? OP is 2 units, meaning from the origin to P, we just go 2 units to the left. And that would make this x value -2. And how does that help us find PR? Well, do you see that if this is -2, P and R are vertically in line with each other. R is a point vertically below P. So that means they have the exact same x value. So it means that this point over here, its x value is -2, and we would just have to find its y value. And once we find its y value, that would tell us exactly the length of PR because it's going from 0 to whatever that y value of that point is. Okay, so we got the x value. We can take that and substitute it into the graph that it is on. It's on the graph of f. So let's substitute it into f. So we're going to find out what f of -2 is. Okay, so this is the graph of f. So we'll say f of -2 equals -1/2, -2 all squared, plus 1/2, -2, plus 1. And let's find out what f of -2 is. And this is -2. Okay, so if it is -2, that is the y value of that point. Okay, so now we know that this y value is actually -2. So if this is -2, what is the length of PR? PR is simply, because it's 0 to -2, it's 2 units. Okay, so there we go. We can finally tell them that PR is therefore 2 units. PR equals 2 units. And that is our answer. Question 5.5 says, consider h of x is equal to q to the power of x. 5.5.1 says, calculate the value of q. Okay, so how do we find that value of q? Well, in order to find that value of q, we would need 1 point because we need something to fill in place of y and in place of x. So do we have a point on this graph of h? Looking at the graph of h, we have the y-intercept, but do you see, because this y-intercept, yes, it was 1, but it's 1 and 0. So here's the thing about that. It's not going to be very helpful because if you say the y value is 1 and the x value is 0, well, you just get 1 equals 1. So it doesn't help you find q. Okay, so look at what we can use. We can use this point A. It's vertically above C. So since it is vertically above C, it means that they share the same x value. See, that x value is 2. This x value will also be 2. They only have a different y value. This has a y value of 1/4. This has a y value of 0. So in order to find q, we can just substitute this point A on the graph. Now that we will know that A is actually 2 and 1/4. So let's go ahead and tell them that A first is 2 and 1/4, and then we'll substitute it into the equation of h. So in place of y, we say 1/4 is equal to, and we say q to the power of 2. And this is our equation. So we're trying to solve for q. How do we get to q? There's a squared, so we need to get rid of that squared by square rooting both hand sides. So since we have a squared, we can square root both hand sides of the equation. Yes, there is a positive and negative solution for the equation, yes, but not relevant to q. You see, the thing about q is a base. It's the base of an exponential function. For it to actually be exponential, the base has to be greater than 0. Q has to be greater than 0. If q is a negative number, that's not going to be an exponential function. That graph is going to basically oscillate between positive and negative y values. It's going to be positive one time, negative another time, positive one time, negative another time. And then it just creates some sort of zigzag pattern, and it's not an exponential function. Okay, so that means that q is therefore equal to 1 over 2. And that is our answer. Question 5.5.2 says, hence determine the equation of the inverse of h in the form of y equals. Okay, so we know now that the graph of h is y equals a half to the power of x because we found out what q was. Okay, so let's just write it as y equals. And so to find the inverse, we first swap the x and y value. So now this is x equals a half raised to the power of y. And to make y the subject, we're going to use log. So we'll just say y is finally equal to log, and our base is 1 over 2, and then we'll put x. And that is our answer. Moving on to the next question. Question 5.6 says, write down the range of h. Okay, so if this is the graph of h, what is its range? The range is all the possible y values of this graph. So focusing on that graph of h and all the y values that it has, do you notice how it does not have any y values? Here, below the x-axis, there are no y values. And this is because this graph of h has an asymptote. Now, right now it's not visible, but the graph of h's asymptote, looking at the equation of h, remember that that graph is actually naturally in the form of y equals an exponential function, right? It's y equals a multiplied by a base raised to the power of exponents, and then there could be a shift, horizontal shift, and then there is plus q. Now, the horizontal asymptote is that horizontal line that the graph will never touch. And right now, we don't see anything by h. There's no plus q at the end. Not talking about this q though. Okay, so because of that, it means that that q value is 0. That horizontal asymptote is 0, meaning it will never cross this line. So it doesn't have any y values below the x-axis, meaning its y values are values that are greater than 0. Okay, those y values that are all greater than 0. That's where it has y values. So for the range of this graph, we can simply say that y is greater than 0. And that is our answer. Okay, so you can either write it like this or like that. And that is our answer. Moving on to the next question. Question 5.7 says, determine the equation of g, the tangent to f at b. Okay, so it's a tangent to f at b. A tangent is still a straight line. So it's in the form of y equals mx plus c. So this means that the next thing we'll need to do is find the gradient. And then, of course, we need that y-intercept. But we'll just need 1 point on that tangent to find its y-intercept. So let's go ahead and see how can we find that gradient if the tangent is at b. So this is b. It means that that tangent line goes something like this. It's going to b and then it just, crosses. It does not really intersect like that. It just touches b only on the graph of f. So how do we find its gradient? How do we find the gradient of this line? Well, it passes through b, and b is on the parabola. So if we could find the gradient of the parabola, then find out what exactly is the gradient of the parabola at this point b, then we have found the gradient of the tangent. So how do we find the gradient of a parabola? You find the gradient of a parabola by deriving the parabola's equation. Okay, so I just got the parabola's equation. This is what it looks like, and we're going to derive this function. So this is f of x, and we'll find f prime of x, and that will find the general gradient of the parabola. Okay, so that is negative 1 over 2 times 2, which is negative x. Exponent minus 1 is 1, and you don't have to rewrite it. Then we have 1 over 2 times the exponent of 1, which is plus 1 over 2. And you'll say exponent minus 1, but that's 0, and anything to the power of 0 is 1. That multiplies to a half to stay a half. So this is the general gradient of the parabola. Now we specifically want that gradient at that point b. Knowing that b is negative 1 and 0. So we're specifically trying to find the gradient of the parabola at the point where x is equal to negative 1. So we'll say f prime of negative 1, and this will tell us that gradient. So negative 1 plus a half. Okay, so that's going to become positive. and 1 plus a half is 3 over 2 or 1.5. So the gradient of that tangent is 3 over 2. Great, we just found its gradient, and now we need to find the y-intercept. We can find the y-intercept by substituting a point on the tangent. The only points that we have on that tangent is B, okay? This is the only point over there. So let's go ahead and substitute that point B, and then we'll have our equation. You can choose to use y equals mx plus c, or you can use this. So y minus y1 is equal to m times x minus x1. And in place of x1 and y1, we substitute -1 and 0. So we'll say y minus 0 is equal to our gradient of 3 over 2 times x minus -1, which becomes plus 1. Y minus 0 is just y, and then we distribute. So this is 3 over 2x and plus 3 over 2. Okay, did they tell us to put it in any format? Not really. They just said of g. So let's go ahead and just call this g of x. So this is g of x equals 3 over 2x plus 3 over 2. And that is the equation of our tangent. Moving on to the next question. Question 5.8 says, for which values of x is x multiplied by f prime of x less than 0? Okay, so we can think about what the graph of f prime of x will look like. And honestly, for this one, we don't really need this part so much, okay? But the graph of f prime of x, because f of x is a concave down parabola, if you derive this, it will give you a straight line with a negative gradient, meaning that that graph is going to move down like that. Okay, so we already have the equation of the derivative. So in this case, it actually makes it a little more simple than, it would have been had they not told us to derive this. So there's that graph of f prime of x. Okay, it's a decreasing function that we have over there. And we just need to look for specific things. So here's the thing about it. This is why I said we don't really need that actual graph. So let's look at the possibilities of that. If x is a positive value and you multiply it by the y value of f prime of x, and that is a negative value, then you will get a negative answer. That is that value less than 0. Less than 0 just means negative. Okay, another criteria we can look for is where the x values are negative and at the same time the y values of the derivative are positive, then it's going to give us a negative value. So here's what we're looking at. We're going to have that graph and it's a decreasing function, but we will need one specific point on this graph. You see, to find out whether the graph of f prime of x has a positive or negative y value, you need to find out where it is equal to 0. So say it was equal to 0 here and it just looked like this. It's going to look like this anyway, so we're going to use this graph. It's going to slope downwards. You see that for all these values over here, it has positive y values. See, positive y values all through here. If you line these points, these individual points to the y-axis, they all have positive y values. And if you line these ones to the y-axis, they all have negative y values. This is why the x-intercept of the derivative of f is going to be very important here. So let's find that first. We already had the graph of f prime of x, so let's just find its x-intercept. Okay, so the x-intercept is where y is equal to 0. So we're going to say 0 is equal to negative x plus a half, and then just transpose the negative x. So x is equal to a half. So now that we know that it's a half, this helps us a lot. So we're just going to look for whether graphs meet this criteria. So first, we're looking for where the x values are positive, and at the same time, the y values of f prime of x are negative. Okay, this is f prime of x. So where do we first have positive x values? Positive x values on the x-axis, they're just all through here. Now for these same positive x values, the graph of f prime of x must have negative y values, meaning it needs to have negative y values. Okay, so that is this section over here. And you see that the graph exists in this category over here. Okay, so now we just have to tell them for which values of x this happens. If you line these points up to the x-axis, you see that this is specifically where x is greater than a half. These are values that are going towards the right-hand side of a half. Okay, so we got that one. We were able to find that criteria. The second criteria we're looking at is where x has negative values and the y has positive values. Okay, so x must be negative while y is positive. Do we have the graph of f prime that exists in this region? Yes, we do. It's over here. Okay, so we're going to say it's all of this over here. So where does that start? You cannot take this part, okay, because this is the section where x is positive and y is positive. That's not what we're looking for. But this part works. So this starts at the y-axis where x is equal to 0, but not exactly at the y-axis because they didn't say less than or equal to 0. They said it must just be less than 0. If you took that x value of 0 here times the y value, the positive y value it has, it will give you 0. Okay, so we're not including the actual x value of 0. So if you line this down to the x-axis, do you see that the x values for which this exists is values that are less than 0, because this is 0 and then its value is less than 0. Okay, so this exists for values of x where x is less than 0. They are not related. We don't have to write them together. And this is our answer. And that is it for question 5.